We are starting now question number 9 for the topic of kinematic for M1. A particle is projected vertically upward with a speed of 40 meters per second alongside a building of height h meter. Given that the particle is above the level of the top of the building for 4 seconds, find height h. The second part of that, 1 second after the first particle is projected, a second particle is projected vertically upward from the top of the building with a speed of 20 meters per second. Denoting the time for the projection, the first particle by t seconds, find the value of t for which the two particles are at the same height above the ground. So, in this case, we will first draw the figure, and then according to that figure, we will calculate the things for that. Let's say this is the ground, and here is the building of height h meter. First particle is being projected from point O with the speed of 40 meter per second. At the highest point, when it will reach A, its final velocity will be equal to 0. So first we will calculate the value of time from O to A for the particle to be projected upward with a speed of 40 meters per second. So V is equal to U plus GT, where V is equal to 0, U there is 40, G there is minus 10 because it is moving upward, and time T there. So T is equal to 4 seconds. So the particle will take 4 seconds to reach at the top and then 4 seconds to reach at the bottom to the ground level of that particle there. But in this case, they are asking that find the height of the building when the particle is above h for 4 seconds. So let's say this is above h, and from time this B to C is basically B towards A towards C is basically equal to 4 seconds. So now we will calculate the height of the building H there. We know that from O to A, V square minus U square is equal to 2GS. V there is 0 square minus U there is 40 square is equal to 2 into minus 10 into the height h there. Let's say this total height above the ground for that particle is denoted by capital H. So H is equal to 40 into 40 divided by 20. So this is equal to 80 meters. It means the first particle is 80 meters above the ground when it is being projected with a speed of 40 meters per second. Now, it remains in air for 4 seconds above the building H there. So that means from B to A, the total time is there 4 minus half of 4, that is equal to 2 seconds. And same is from A to C. the time there is same, so it is also equal to 2 seconds. Now, if we can calculate this height from A to this position, let's say that is h1. Then from this total height of the projectile minus this height, that is giving you this height total there. So we have calculated the total height h there is equal to 80 meters. From this 80 meter, if we subtract this height, then it will be the height of the building there. So here at A point, when it is coming downward, U is equal to 0 for position for A there. And G there is 10 meters per second square. So we can use this equation S is equal to UT plus half GT square. So S there is H1, U is 0 into 10 plus half into 10 into 2 square. So this thing is equal to 20 meters. So height of the building is equal to small h, which is 80 minus 20, and that thing is equal to 60 meters. So this is the height of the building from the ground, which is equal to 60 meters of that part there. Now in the second part, after 1 second, the second particle is being, no, let's say this is the actual situation, that particle start from O, projected upward with a speed of 40 meters per second. And from this top of that building, which is we have calculated equal to 60 meters, after 1 second, that particle is being projected upward. And we are going to calculate the height of these two when they are at the same level. So we have to calculate the time for that when they are at the same height h there. Now for this portion, we know one thing, that the first equation is given in terms of the time t there. They have not mentioned. So we can calculate v square minus u square is equal to 2gs. But time is not mentioned there, so we can use time formula for that. S is equal to ut plus half gt square. So S is equal to ut plus half gt square for the first particle. So S is equal to 40t minus half into 10 into t square. So this will become 40t minus 5t square is the distance traveled by S when it is moving upward and takes t time in that part. So when the second particle is being projected upward after 1 second from a height of 60 meters, so for the second particle, S is equal to ut plus half gt square. So this is equal to u is 20, time is there t minus 1, because after 1 second is going to be projected, minus half into 10 into t minus 1 square. So this will become 20 into t minus 1 minus 5 into t minus 1 square for the second particle. But second particle is already 60 meters above the ground. So if it is 60 meters above the ground, then S will be equal to 60 plus 20 into t minus 1 minus 5 into t minus 1 square. So they are asking find the time when they were at the same height. So this distance S and this distance S are equal. So we can make the equations of this portion that 60 plus 20t minus 20 minus 5 into t minus 1 square, that should be equivalent to this height, that is 40t minus 5t square. Now this will become 60 plus 20t minus 20 minus 5t square minus 2t plus 1. It should be equivalent to 40t minus 5t square. So from this, after doing the calculation, sixty plus 20t minus 20 minus 5t square plus 10t plus minus 5 should be equal to 40t minus 5t square. So this 5t square and 5t square cancel out. Then t value is being calculated there equal to, this is 20t, this is 40t, this is 10t. So 20t plus 10t, 30 and 40, so that is 10t. And 60 minus 20, 40 minus 5. So 35t, 35 is equal to 10t, or t is equal to 3.5 seconds. So this is the time when they are at the same height from the ground, when they are being projected from O and the other particle is being projected after 1 second with a speed of 20 meters per second. So this is the complete solution for this projectile motion of the particles when one particle is thrown upward from a height 60 meters after 1 second.